Okay, question 10 involves a supermarket in which historical records suggest that 30% of customers buy baked beans in single tins. A sample of 20 customers is taken to see if there's been a change in that proportion. It's not saying which way the change might have been, it's just asking the question about whether or not there's been a change. Hence, it's a two-tailed test. We're going to sort of test the lower end and the upper end at the same time. So, first up, we need to think about what the distribution is. Well, we've got N as 20 customers, that's fixed, and the historical records suggest 30%, which is 0.3, 30% of customers buying them in single tins. Okay, so that means then in part A, when we're doing our hypothesis test, our null hypothesis is going to be that P equals 0.3. Our alternative hypothesis, because we're only interested in whether or not there's been a change, either way, either go down or up, our alternative hypothesis is that P is not equal to 0.3. Okay, it's a critical region test, so what we're looking for is the critical region. And so, first of all, working for the probability at the lower end that x is less than or equal to some critical value C1. And we're asked to say that the probability of rejection in each tail should be less than 0.5. So that's got to then be less than 0.5 in order for it to be critical, in order for it to therefore be rejected. Okay. Now at the upper end, got a similar kind of thing, but at the upper end we're looking at a greater than scenario. Critical value this time being C2, just let's say. But again, to fall into that, to form a critical region at the upper end of our distribution, so say a distribution, not that it's going to look exactly like that, but something like that. At the upper end there, that's got to be less than 0.05, and similarly at the lower end, that's got to be less than 0.05, that's going to be C1 and that's going to be C2 respectively. Okay, so greater than or equal to C2, still supposed to be less than 0.05 there. Okay, now for the less than or equal to form here, it's quite straightforward. We just get out the cumulative tables in the formula booklet again and scan down. So n equals 20. Probability is 0.3, which is this column here. And what we're looking for then is the first time there, the time that it's less than 0.05. So 0.1071, well that's not less than 0.05, but 0.0355 is less than 0.05. So that's the one we're interested in. And that reads across to 2. Okay, so that means that then probability that x is less than or equal to 2 is equal to 0.0355, which is less than 0.05. And if you want to justify that, you could also write down the probability that x is less than or equal to 3 is 0.1071, which is more than 0.05, so that's not allowed. So hence, this is the one then that we are interested in there. Okay, and therefore our first critical value at the lower end is 2. Now the upper end is somewhat more tricky because it starts with a greater than or equal to symbol, and as we know, to get it in the form where you can look at the formula booklet, you need to flip it around to a less than, or preferably less than or equal to. What's relatively straightforward is to flip it around to make it strictly less than C2. So if it can be greater than or equal to this value, say the value is 10, for example. If it was greater than or equal to 10, then it would be 1 minus probability that x was less than 10, or less than or equal to 9. But you can think of it as strictly less than 10 for the minute, and less than 0.05 there. Okay, you've got a little bit of rearranging to do because we've got a minus probability here. So if you add that across to the other side, but then subtract the 0.905 across to this side, that's our resulting statement. Let's put this on the left just for convention. But it was on the big side of the inequality sign there, so that's greater than, and this 1 minus 0.05 is 0.95. Okay, so what we then, we've got it into a sort of less than situation. Let's just see what the formula booklet says for us. So this is the column for 0.03 there, sorry, 0.3. And let's just check. Greater than 0.95. So the first time it's greater than 0.95. Sorry, this column here. First time it's greater than 0.95 would be here. 0.9520. That reads across to 9. Okay. So what we can say then is probability that x is less than or equal to 9 is 0.9520, which is greater than the 0.95 we were wanting. Okay. If it's less than or equal to 9 though, then that's strictly less than 10. And I've done that to try and get it in the same form I had it here. So that was strictly less than C2. So I wanted to get this statement in exactly the same form, so I just compare the places. So the place there, C2, is now taken with the position of 10. So therefore, C2 equals 10. Okay. So quite complicated on the high side there. But the resulting critical region then, is on the low side, we can have x less than or equal to C1, where C1 is 2. On the high side, we can have x greater than or equal to C2 there, which is and where C2 is 10. And this is written in set notation with the union symbol there, linking the two together. So critical region is either x less than or equal to 2 or x greater than or equal to 10. In part B, we're asked to state the actual significance level of the test from part B. Just a reminder, the critical region came out as x less than or equal to 2 and x greater than or equal to 10. So to work out the actual significance level, then we actually work out what the probability of getting x less than or equal to 2 is. Well, we did that earlier, and if we just look back in my pad here, we've got it highlighted here, it was 0.0355. Okay, similarly, at the top side, probability that x is greater than or equal to 10. Let's just have a quick look back at what that was. Well, that's less clear cut, because what we ended up with was probability that x less than 10 is 0.9520. So a little bit of work to do here. Probability that x greater than or equal to 10 is 1 minus probability that x is strictly less than 10, or less than or equal to 9. Okay, they're one and the same thing. Looking at that earlier, we had 0.9520, and 1 minus 0.9520 is going to be 0.0480. Okay. So, top side, that's the actual significance level. Bottom side, that's the actual significance level. So the overall actual significance level is going to be the sum of those, so 0.0355 plus the 0.0480, and that gives me 0.0835. Okay, in part C then we're told that the actual number of customers that, out of the 20 that bought baked beans in single tins was 11. Now, this was our critical region, remember, x less than or equal to 2 or x greater than or equal to 10. Now, 11 is greater than or equal to 10, so therefore it's inside this critical region. Okay, and if it's inside the critical region, we reject the null hypothesis there. So it tells us that there's sufficient evidence at this significance level of 10% to reject the null hypothesis and therefore accept that there's been a change in the proportion of customers buying beans in single tins.